All right, today we're going to look at section 8.2. We're going to graph simple rational functions. Today is going to be to graph the simple rational functions. They're going to look like this picture down here to the left. They're going to have a vertical asymptote, they're going to have a horizontal asymptote, and they're going to have kind of like this curved-like feature. They actually should have arrows on both ends, implying that they go on forever in both of these directions. Notice that they're also symmetric to each other. So this is what a rational function looks like. It's a polynomial divided by a polynomial, and then q of x, the bottom part, cannot be 0, because again, you can't divide by 0. So none of this you need to write down yet. So this is what you need to know, and again, don't write this down. I'm just kind of talking and making sure that you understand what's going on. So these are called hyperbolas, right? In English you have hyperboles, but this is called a hyperbola. So hyperbolas have a vertical asymptote that's an x equal line. So we learned in Algebra 1 that x equal lines are vertical lines. So this graph here actually has an x equals 0 line. They also have a horizontal asymptote, y equals line. So this is a y equals 0 line, because that's where the asymptote occurs at. Asymptotes are boundaries. So it's like a wall that the function cannot cross. It can get infinitely close to the function, or to the asymptote, but it can never, ever, ever touch this line x equals 0, right? So it can get really, 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 really close, but it can't ever touch it. Kind of like electrical fence. You could get really close to it, but if you touch it, it's going to shock you. So not the best idea. The domain is x can be anything it wants to be. So x is an element of all reals, except it can't be the vertical asymptote. In this case, 0. Y can be anything it wants to be. So y is an element of all reals, except for the value of the y asymptote. So y cannot be 0. And both of the branches, that's what these things are called, are symmetrical. And so for each xy, so like for this point here, this xy, there's a corresponding negative x, negative y, which is kind of cool. This you either need to print out from online on the website, or you need to write this down in your notes. All right, so either print this page out, cut it out and tape it into your notebook, or write this down. You're going to want to write this down, right? So make sure you write this down. Every single word, every single thing on this page, write it down. All right, when you're done writing it down, go ahead and restart the video. You're going to want to write this down, or you're going to want to take a picture, or print this out and put it in your notebook. Write this down. It's really important that you write both of these pages down. Notice that they're a little bit different. The last slide didn't have the ax plus b or the cx plus d. So make sure that you write both of these down because they're both different. So when you're done writing it down, then go ahead and restart the video. All right, so we're going to do one example here. So the first thing we have to do is we have to decide if it's like the first example, the first set of notes we wrote down, or the second set. And you can tell by looking at the numerator and the denominator. If you look at the numerator, it only has one single number, and the other part is that it doesn't have like an ax on top or like a cx on the bottom, so there's no x on top and no x on the bottom, and that's what we're looking at to differentiate between the first one and the second one. The other thing we're looking at, there's actually a third type, but it has a degree of greater than 1. So if we look at this guy, it has a degree of 1, and it does not have an x on the numerator. So we're going to go ahead and start. First thing we're going to do is 1, find the vertical asymptote. So the vertical asymptote is x equals h, which is on the bottom. So x equals 1 is our vertical asymptote. Right? So if I was going to graph that, that would be right here. So x equals 1. Sorry, not the easiest thing to do with an iPad pen. So if you remember, vertical lines are x equal lines, right? We learned that in Algebra 1 and pre-algebra. Step 2 is to find the horizontal. So this guy was h, and this guy is k. So y equals 2 is our horizontal. So that is a horizontal line at 2, right? Again, same thing we learned in Algebra 1. All right, so those are called our asymptotes. I made them dotted on purpose because that's what you do with asymptotes. You make them dotted. So those are the lines that the function cannot cross. They're boundaries. The function can get infinitely close to it, but it cannot touch any of those dotted lines. All right, step 3 is to make a t-chart. Choose to the left and to the right of the vertical asymptote. So what I do is I just look here at the vertical asymptote, which is at 1, and 2 numbers to the left. So here's 1 number to the left, which is 0, and 1 number to the left is -1. So I'm going to write down 0 and -1. I'm going to go back to the vertical asymptote, and I'm going to go 1 number to the right, which is 2, and another number to the right, which is 3. So I'm going to write down 2 and 3. And then I'm going to plug these numbers into the function. So I'm going to put 0 right here where x was. So 0 minus 1 is -1. 3 divided by -1 is -3. Plus 2 is -1. Now I'm going to take -1 and I'm going to plug it in. So that's going to give me 3 divided by -2, which is -1.5, plus 2, which is -1/2. Oops, +1/2. All right, so now we have 2. I'm going to take 2, this 2, and I'm going to plug it into the function. 2 minus 1 is 1. 3 divided by 1 is 3, plus 2 is 5. All right, and then I'm going to take 3. I'm going to plug it in, so 3 goes in here. So 3 minus 2 is, or 3 minus 1 is 2. 3 over 2 is 1.5. 1.5 plus 2 is 3.5. All right, so now we're going to graph those points on our graph here. So I'm going to graph 0, -1. So over 0, down -1. I'm going to graph -1, +1/2. So left -1, up 1/2. I'm going to graph the point 2, 5. So over 2, up 5. And I'm going to graph the point 3, 3.5. All right, so this looks like this. Kind of comes along and then he curves along the asymptote. They can never touch the asymptote, but they can get really, really close. So it goes along the asymptote, comes here, curves, and comes down. So that's what the two functions look like. That's the hyperbola. All right, and the last part is to do the domain and range. So the domain, x can be an element of all reals, except x cannot be 1, because that's where the vertical asymptote is. The range, y can be anything it wants, so y can be an element of all reals, except y cannot be 2. Right, again, because that's where the horizontal asymptote is, and so those two things restrict the domain and the range. But it can be any other number it wants, that's why they have arrows implying that it can go on forever and ever. All right, and so we'll do some more examples in class tomorrow. This kind of gives you a head start. 2 things you must do. You must have those 2 note pages written down or pasted into your notebook. Please do not come to class without either of those 2 things done.